All right, section 5.1, we're going to talk about linear equations. And I know you looked at linear equations back in Math 1240. What do you remember about linear? What does the word linear mean to you? Line. All right, so tell me what you know about lines. They're pretty liney, okay.
Straight, they have a direction.
They're straight, they have a direction. Slope. All right, there's an important word. What's slope? It's there's a little formula for it. Usually slope is called the letter M. And I don't know why we use the letter M, but we do. And a little mnemonic we remember for it is rise over run. Do you remember any other little formula for slope? All right, that's a different equation. Y equals mx plus b. I was thinking of, there's a formula here for slope that has like a y2 and an x2. And y2 minus y1, that goes up on top, because rise is on top and rise is up and down, and y's are the ups and downs. And x2 minus x1 goes on bottom. All right, so there's our little formula. You might also see this one sometimes. Delta y over delta x, where delta stands for change. So in a physics class, they tend to write it that way. In a math class, we tend to write it y2 minus y1 over x2 minus x1. All right, y equals mx plus b. That's a very, very important equation. What's that one? It's called slope. I think I heard the right words. Slope-intercept form. This is called slope-intercept. I didn't leave myself enough room. Form of a line. Y equals mx plus b. And it's called slope-intercept because m is the slope. And what intercept are we talking about? The y-intercept is the point 0, comma b. All right, so that's a very, very useful equation of a line. Y equals mx plus b. All right, what else do you remember about lines? They what? They either have an end or they don't. Actually, lines don't have an end. A line segment might have an end, or a ray. A ray is half of a line. A line segment is a chunk of a line. Lines go on forever, though. They don't have an end. What else do you remember? Anything? What's that? What about 2 points? 2 points determine a line. Okay. 2 points determine a line. In fact, once I know 2 points, I can use the slope formula up here to find the slope of that line, can't I? So if I know 2 points, I can find the slope. And then how do I find this b number? How do I find that intercept? It's the y-intercept? But what if you don't know the y-intercept? For example, give me 2 points. Give me 2 numbers. 5 and 3. All right, so there's 1 point on our line. And give me 2 more numbers. 2 what? 2, 2. All right, so you guys were nice. You didn't pick any fractions or decimals or anything. That was thoughtful of you. I appreciate that. All right, so there's 2 points. Once we have 2 points, we can find the slope. M equals. Which number is y2? This 2 over here? All right, so it's going to be 2 minus 3. And then I subtract my x's. That's 2 minus 5. So that's negative 1 over negative 3. That's 1/3. All right, so y equals mx plus b. I know this is going to be 1/3 x plus b. My slope is 1/3. How do I find that b number? I don't know. I solve for b. Yeah, I don't know the y-intercept. See, somebody should have been really clever and given me one of the points as 0, comma something. Oh, you tried. I didn't listen to you. Yeah, I didn't listen to you. That makes it too easy. Because if I have 0, comma something, then I know the b number. But I don't have that, do I? So what we have to do, somebody said it, is we have to solve for b. So you pick one of the 2 points. Which one do you like? 2, 2 looks easy. So I'm going to take 2, 2. I'm going to plug 2 in for the x, and I'm also going to plug 2 in for the y, and then I'll solve for the b. So I would have 2 equals 1/3 times 2 plus b. That's 2/3 plus b. So to get the b all by itself, I subtract 2/3 on both sides. What's 2 minus 2/3? 1 1/3. I'm not a big fan of mixed numbers, so I'm going to call it 4/3. I prefer improper fractions myself, but if you put 1 1/3, if you wrote that on a quiz or a test, it would be okay. I wouldn't mark it wrong. So y equals 1/3 x plus 4/3 is the equation of that line. So you're absolutely right. 2 points determine line. All right, so I have some questions. Y equals 2x squared plus 3. Is that a line? Why is it not a line? Because the x is squared, that's correct. As soon as you have an x squared, it's no longer a line. And this one does happen to be a parabola. You're absolutely correct. Y equals 5 square root of x. Is that a line? No, why not? Because we're not allowed to have square roots to be a line. Anybody know what that graph looks like? Yeah. It's half of a sideways parabola, correct? This is a parabola that goes up and down. This is a parabola that goes right and left, but you only have half of it. That's what that looks like. Y equals 3x to the negative 4. Is that a line? Yes. Anybody want to vote for no? How could you tell? If you don't know. Okay, so what you're telling me is I could rewrite this as 3 over x to the 4th. You're absolutely right. Negative exponents drop things to the bottom. Was it a line? You don't think it is? Why not? I don't think it is either, by the way. So. Well, if it's x squared, then it turns into a quadratic. Once I put any other exponent on it, it's no longer a line. So it doesn't matter if this is a positive 4 or a negative 4. This could be a 6 or a negative 8 or a 1/2 or a 4/3 or whatever. Once I put an exponent on the x or I put an exponent on the y, it's no longer a line. All right. So, looking at this. An equation is called linear in the given variable set if each term contains only one variable to the first power or as a constant. So when you ask a math person, what does the word linear mean to them? A math person would tell you linear means I only have x to the power 1 or y to the power 1. I never have squares or cubes or square roots or exponents of any kind. So that's what this is saying. For an equation to be linear, each term has one variable, and the variables only have first power. So all these other things that I was writing here, this x squared, this square root, this x to the negative 4, none of these are linear. Okay? So that's what linear means to me. To me, linear means all the exponents are all 1. And then it says, for example, the equation 6x minus 4 equals 20 is a linear equation in one unknown. You have already learned how to solve such an equation. All right, well, what is the answer? How do you solve that equation? X equals 4. Yeah, you do it in your head, don't you? That one's so easy. What did you do in your head? You added the 4 to both sides, so 6x is 24, and then divided x is 4. All right. So you've studied linear equations in the past. What we're going to study in Chapter 5 are things called systems of linear equations. And the word systems is a fancy word, which simply means more than one. Systems of linear equations. And all this means is more than one linear equation. So that's what we're going to study in Chapter 5. In Chapter 5, we're going to learn several different techniques for solving systems of equations. And we'll also look at some examples of why we might want to know about systems of equations. What are they good for? All right. So, looking back at this. Suppose it is given that the perimeter of a rectangular plot of land is 180 meters, and we wish to find the length and the width. This information gives us a linear equation and two unknowns. 2L plus 2W equals 180. Why is that linear? Everything has first powers, isn't it? Is there any L squared or W cubed or anything like that? Nope. So that's linear. Powers are all one. A solution to this equation must include a length and a width, which then substituted makes it true. There are many different combinations of lengths and widths that make this equation true. Can you find 5 such combinations of numbers? Well, actually, what it's saying here is that there are many different correct answers. So, for example, all right, so I'm going to brute force it. I'm going to tell you the length is 10. If I tell you that the length is 10, can you find the width? Yeah, how would you do that? Well, you would plug it in, right? 2 times 10 is 20. So we would then subtract the 20 on both sides. 180 minus 20 is 160, and then we'd have to divide by 2. 80, so W is 80. Why not? So? Yeah. That's correct. Right. A square is a rectangle. So what you did is you just found another correct answer. Another correct answer could be length is 45, width is 45. You might not like it, but that is a correct answer. That would be a square. What if I told you length is 100? All right, so can we still solve that equation? Can we find a value for W? Yes, but that value doesn't make any sense in this problem, does it? But we could find an answer. Let's see, if W is 100, that's 200. So we get, subtract negative 20, W would be negative 10. So while that equation does have an answer if L is 100, it doesn't make sense in this problem. We cannot have a rectangle with negative width. So you end up with situations like that too. We would call this, there's actually a fancy name for this. This is called model breakdown. Where you get an answer, but the answer doesn't make any sense. All right. So, could we find 5 answers? Yes, we could. How many answers are there? A lot. How many is a lot? An infinite number of answers, aren't there? Because I could plug in fractions, decimals. Yeah, as long as I picked a number for length, it would have to be smaller than 90, wouldn't it be? What's special about 90? Yeah, once I do 90, 90 times 2 would be 180. That would take up everything. So I could pick any number between 0 and 90 for length, and I would get an answer for width. So yeah, there's an infinite number of correct answers. All right, so this says, as you can see, there is not enough information to decide exactly what the length and width are. There are many possibilities. In order to have enough information to determine the length and the width, another equation is needed. And I think that's what you were getting at, is that you can't solve it efficiently.
You have to create a second equation.
Correct. So the general rule is if I have two variables, as we did in this equation, length and width, if I have two variables, how many equations do I need? 2. And if I have 3 variables, how many equations do I need? 3. And if I have 10 variables, how many equations do I need? Unfortunately, I would need 10. You need 1 equation for every variable to be able to get one exact solution. Now, if I have 2 variables but only 1 equation, I get many, many solutions, and that's okay. If I had 10 equations but 15 variables, then I have more equations than I do variables, I would still get an infinite number of solutions, probably. That's what you want to get in. All right. So that's what it says down here. We will need as many equations as there are unknowns in order to determine any unique answer to the problem. All right, so now suppose that an additional piece of information is given. The length is twice the width. So here's that equation. Length is twice the width. We now have 2 equations. This is called a system of linear equations in 2 variables. And so that's what I said before. A system of equations is just more than 1 equation. And there it is, there's 2. There is now enough information to determine a unique value for L and W. The solution of this system is the pair of numbers for L and W that make both equations true. So it asks, is the solution L equals 50 and W equals 40? No? Why not? It doesn't fit the second equation. It fits the first one, doesn't it? Because if I plug in 50, 2 times 50 is 100. And I plug in 40, 2 times 40 is 80. So 100 plus 80 is 180. It works in the first one. Does it work in the second one? No. So to be an answer, it's got to fit both of them, not just one, but both. Is the solution L equals 60, W equals 30? 30 times 2 is 60. Let's see. 2 times 60 is 120. 2 times 30 is 60. 120 plus 130 is 180. So, yes, that is the correct answer. Questions on that? How did I come up with those 2 numbers? How did I come up with L equals 60 and W equals 30? All right, so it turns out that's one way to do it. That's not the common way, but it's the correct way. There are lots of ways to solve, and that's what we will learn in the rest of Chapter 5. For now, you don't have to worry about how I actually came up with those numbers. We'll learn that in Chapter 5. And so that's what it says next. In this chapter, you will learn several different methods for finding the solution of a system of equations in either 2 or 3 unknowns. Systems can be solved graphically, algebraically, or by using something called determinants, whatever the heck those are. We'll find out what that means later. For right now, however, the important thing is that you understand that when there is more than one variable in a problem, you need more than one equation to find a unique solution. You must know that any given set of numbers represents a solution to a system only if, when substituted, all the equations are true. All right, so we have 2 more examples here. The forces acting on a link of an industrial robot must satisfy the following systems of equations. F1 plus F2 equals 35, and 4F1 has to equal 6F2. Where did they get those 2 equations? Why does F1 plus F2 have to equal 35? What's that? All right, so there's a force of 35 pounds going up. So for this to be in equilibrium, how much force does there have to be going down? 35. So that's the force 1 plus the force 2. The force going down has to equal the force going up. So there's the first equation. And how about the second one? Why does 4F1 have to equal 6F2? Correct. It's like this bar here is like a seesaw or a teeter-totter. So what has to happen is the distance times the force has to equal the distance times the force. Otherwise, that thing is going to have torque on it and it's going to twist. So for this to stay in equilibrium, distance times force on the left has to equal distance times force on the right. So there's where those two equations came from. They're not anything magical. Basic information about force. Is that an answer? F1 equals 21, F2 equals 14. Is that an answer, yes or no? Well, it could be, because it works in the first one. 21 plus 14 certainly is 35. First one's easy to check. All right, what's 4 times 21? 84. And what's 6 times 14? Also happens to be 84. So is the second equation true? Yes. So that is a solution. All right. And then a little chemistry. The amounts x and y in cubic centimeters of two liquids used in making a mixture satisfy the following system of equations. X plus y equals 10. 0.5x plus 0.1 y equals 4. Anybody know where those two equations came from? Yeah, this one's a little harder. What you have here is, I like to think of this as, you have two beakers of solution, and you're dumping one into the other, and you're coming up with a final solution. So what's happening here is this first beaker is a 50% solution. I don't know what kind of solution it is. Let's call it an acid. So this one's 50% acid, and I don't know how much is in there. It's X. The second one is a 10% acid, and I don't know how much is in there. I'll call it Y. When I get all done, I have 10 cubic centimeters in that bucket because I see x plus y equals 10. So the amount in the first beaker plus the amount in the second beaker has to equal the total amount. So it's actually very similar to the first problem. The force going down plus the other force going down has to equal the force going up. This one is the amount of stuff in the first beaker plus the amount of stuff in the second beaker equals the total amount of stuff after you dump them together. And then the second equation is, if I take 0.50x, that's how much acid is in that beaker. And then the 0.10y, that's how much acid is in that beaker. So the amount of acid here plus the amount of acid there has to equal the total amount of acid. So how did that come out to be a 4? This one's 50%, that's 10%. When we mixed them together, what percent are we going to get? Well, it turns out to be a 40%. Because 40% times 10 would give me the 4. So I take percent times amount, that's how much acid I have, so that has to be percent times amount. So anyway, that's where those two equations came from. At this point, you're not going to have to worry too much about where the equations came from. I just wanted to give you a little preview of what's going to come up in some future sections. What we need to concern ourselves about is 8 and 10. Is that the right, or 8 and 2? Is that the right answer? Well, 8 and 2 makes 10. It doesn't work in the bottom one. 50% of 8 is 4. And no matter what else I add, I've got too much already, don't I? Because 10% times 2 would be 0.2. So yeah, that's not the right answer. We got too much acid. That one doesn't work. Questions?